Hi everyone. So this is a video about how to extract some channel information. We're going to get some channel profile information, do a chi transformation. So this is using the integral method of channel analysis. And we're going to look at the file type that gets spat out by lsdtopotools. So I'm working in Google Colab. I've done the 3 initial steps that you always need to do in Google Colab before you start working with lsdtopotools. So I've installed our Python wrappers and visualization routines in this first step. I've then used Conda Colab that allows me to install the Conda Forge version of lsdtopotools. So we can always check if lsdtopotools is working by just calling one of the command line programs, lsdtt basic metrics, and asking what version we've got. And, missed an S out. And so we've got it installed. We're working on version 0.9. I want to download some topography from Open Topography using the Python interface. So whenever I want to do that, I've got to have a little file that contains my Open Topography API key. So there's other videos telling you how to get the Open Topography API key, but you paste the API key into a little file called you can name that my OT API key. And then in Google Colab, if you press on that little file button, you can drag and drop your file in. So I'm just going to drag and drop my file in. And there's my API key. Okay, so next I'm going to download some data. And this uses our Python wrapper for doing that. I copy and paste from other notebooks. So I'll just look on one of there's many notebooks in our GitHub repository. So many of these start with downloading some data from Open Topography. So I'll just copy some of that code. So here we go. I'll get one from here, copy and paste that in here. Okay, so the main difference that we're going to do from any other bit of this is I will change the latitude and longitude of the corners of this. I'm going to pick a site in Turkey just because. So in the eastern part of Turkey along the coast. So I'll just call this, I don't know, TU, because I don't want to type very much. Okay, so here are some nice catchments I can see in the map. I want to get maybe 3 of these catchments, 4, that's a nice catchment too. So I'm going to click on the lower left corner. For this to work, you have to capture the entire catchment. You can't cut catchments off. So I'll pick the lower left corner down here. Let's go down here. That's the lower left corner. And I'll pick an upper right corner. So I want to get, these basins are all quite nice. Let's not get carried away. Well, we'll just get it out to here. So there we go. And I hit Control Enter to run that. And after this thinks for a little while, it will download the DEM that I want. Frequently, I just like to check if I've got the right place. So what I'm going to do, well, actually, before I do that, I'm going to find some basin outlets. So again, I'm working from this chi coordinates from basins file right now. So that has come out. Let's find some basins. So if I go onto here, we'll zoom in. Let's try and get this basin here. So that's one basin there. Place that. We'll get, let's see. This is a nice basin here. Paste that in. And I don't know, maybe one more. This basin looks quite good too. Let's get that one. Okay. So let's get that basin. Okay, and I just close this. So I end up with what this step is doing. It's just making a CSV file that contains the latitude and longitude of the basins. When I'm working for research, I tend to not use the Python interface. I just use command line. So I would just write this CSV file straight into a text editor. But you can do it inside this Python notebook this way. Okay, so I've got these three basins. Let's just see where they are. So this next command is going to show me where the basins are. So I'm using some parameters. I'm printing the basin raster. I'm writing the hillshades because I need the hillshade raster. It tells me to get the basins from the outlets, and it's going to get the basin outlets. I'm also telling it to do something called print chi data maps, which is it prints out transformed channel profiles, so you can get channel profile information from this. It uses the command line program lsdtopotools chi mapping. So that's the one that has a lot of these sort of routines for tectonic geomorphology. Actually, I'm going to add one more thing in here. So I'm going to do a channel steepness analysis as well. And again, I wrote the software, but I sort of always forget the names of the routines. So I just look for the routine that I need in some other file. All the command line tools have a help file associated with them. So actually, let's look at that right now. So lsdtopotools chi mapping.h. If I run that, what this will do, it will print out a CSV and an HTML file. So in the Python page, we might go to the CSV file. Okay, so there is a notebook called Getting Started with lsdtopotools. Actually, here it is, How to Get Started. So if you do the help file, you can look at what's in the help file by importing that CSV into pandas. And I'm going to do this so I can use the, well, first I import it into pandas and look at it. Let's have a look. Where did my file go? Oops. Oh, why did this not work? Okay, so that just looks at the top of the file. What I want to do is I want to isolate the Boolean. So Booleans in here are usually the switches that turn on or off an analysis. So I want to look at the Boolean versions. So let's replace this data frame. Again, you can just copy and paste. You don't need to know what you're doing in Python. And this one will give you the top 20. There's quite a lot of them. Let's look at the top 50 here. Okay, so the one I'm looking for, there's all sorts of these. So the one I want to look for is one that gives me all the segmented channels. The reason it's using a segmented channel is because it uses this algorithm, a segmentation algorithm, which separates channel reaches. So here is the thing that I wanted. So I'm going to use this in my analysis. So let's go back to this place where I was going to run the code. So I want print segmented and make that true. I'm doing this live, so hopefully it doesn't break, and that should be fine. So the default concavity index, I think, is going to be, well, let's look. So we can go back to here. That one gave us all the Booleans. The concavity index is set as a float. So float. Let's have a look. So because of historic reasons, in the code, this is called M over N instead of the concavity index. The default is 0.45. Let's change that, or sorry, the default is 0.5. So if we want something else, 0.45, for example, we need to set that. So let's set that in my command here. Whenever you have a command, the way you give it to the command line programs is by making this dictionary. And this is the format of the dictionary. You have the name of the parameter, you have this colon, and then you have what the value of the parameter is. Even if it's a float parameter, the dictionary has to be in a string, so you always need quotation marks around it. Okay, so let's just do this. I'm actually going to move this cell down to the bottom. And we're going to hopefully see if this works. The segmented MCHI map thing is fairly memory intensive or compute intensive. So it might take a little while for that to run. We'll just see how long this goes. And while that's running, what I'm going to do is I'm going to copy over a bit of code that will allow us to look at the basins that we have. So let's have a look at that. Let's print the basin map. Looks like that's working a bit. I've got the hill shade already. It's got the basins. It's probably now thinking about the segmentation. I need to make sure I've got the right file name here. So I started with it being called TU Copernicus 30. So let's just make sure that I've got the right thing. TU Copernicus 30. Actually, I know now, so it's thinking about the segmentation, but it looks like I've got the basins already. So I should be able to run this part of the visualization code. So let's just try that. Well, anyway, that finished. So that runs it, but I've captured the image, so it's printed to a PNG. So I want to look at that image. Let's look at the image. I've set the DPI at 600, so it'll be kind of big. But here's our three basins. Okay, now let's just have a little look at what the files look like. I'm gonna use a Linux command to look at the files, and I just want to see what CSV files I have. So I have the basin outlets, I have the chi data map, and I have this thing called mchi segmented. So this just has the chi coordinates in it. This, on the other hand, has all the channel steepness indicators in it. So we can use pandas to look at what's in that data. I'm just gonna go up to my pandas read thing. So I'm going to read first the chi data map. Okay, and I'm going to look at the basins, actually. I'm just going to call it the same thing as before, chi-map df, so I'm replacing that data frame. So what do I have? I have latitude, longitude, so this is every pixel, essentially, in the chi-map, the chi coordinate, the elevation of that, the flow distance, the drainage area, and then these keys which indicate what basin it's in and what the source key is, the sources of each tributary, so you can isolate tributaries by selecting a source key. What about the other one, the mchi segmented? It's going to have a lot of the same stuff, but it will, in addition, have channel steepness. So this one has a bit more information. The main thing it has different to the all chi or the chi data map one is mchi. So mchi is the same as the KSN or the normalized channel steepness, as long as your default drainage area is 1 meter squared. But that's the default. That's the default drainage area. So really, mchi is pretty much this, unless you do something strange in your analysis, it's the same as the normalized channel steepness. And the normalization is using the concavity index that we programmed before. So this is normalized by a concavity index of 0.45, which I set in the analysis. So that's the concavity index, and so that's normalizing all these chi profiles. So how do we look at the chi profiles? There's a bunch of visualization routines in lsdtopotools, but you can just do a scatter plot with Python. So we can isolate maybe one of the parameters. So let's just, I don't know, we'll take this one. So I've replaced this data frame here. So we do data frame. We'll do the basin 0. And I just do basin key. And I set that as 0. Actually, let's do, so source key is going to isolate just a single channel. Single channel, and let's see. Okay, so now I've got this. Oops, I don't need 50. Let's just look at 5. So, oops, why did it do that? I don't want 55, I just want 5. Okay, now I could do a little plot of this. So let's see if I've got a bit of code for doing this before. Well, I can do this. Again, it's nicer to just copy code than write it from scratch. So what I want is, I've got to redo this. So this is B0DF. So I don't need this code. I do B0DF, B0DF, B0DF. So this one, I'm doing the chi coordinate against the elevation, and I'm coloring it by the flow distance. So what happened here? Oops, I got this B0. Where did I mess this up? Right there. I've already isolated basin 0. I don't need this in here. Okay, so this is the chi profile in basin 0. So we can color this by mchi. So let's try and color this by mchi. So that's now colored by mchi. You could put legend in here if you wanted to. You could isolate different source numbers just by doing the same selection in pandas. If you wanted to plot, say, the channel steepness as a function of chi, you could do it like this. So here, same code, but instead of plotting chi against elevation, I can plot chi against m chi. And maybe I'll color it by the elevation. So this is chi, and this is actually KSN. So that is how you would get a plot of KSN along a particular channel using LSD topotools. Hopefully that was useful for you.